Okay, so we are coming into the home stretch for this section. So just to recap, if I've got a forcing function, which is a power function that has power n, then I'm going to guess, my guess for a particular solution would be the most general polynomial of degree n. So I do want to include all of the powers of t in my guess. If I've got some product of an exponential and a cosine, or an exponential and a sine, even if it's just one of the cosine functions or just the sine function, my guess is going to include both of those parts. So I would guess some constant times exponential cosine beta t plus some constant exponential sine of beta t. So now what I want to talk about is, well, what happens when we take products of some of these functions that we've learned how to guess for. So for example, if I had a power function times an exponential function, well then our guess is going to be the most general polynomial that has that power times the exponential with that power. And again, we might need to multiply by t if we have some resonance with the homogeneous solution, and maybe even t squared if we have resonance with a homogeneous solution which has a repeated root. So let's take a look at example number 5, where we've got this second order differential equation. So before we come up with a guess for a particular solution, we always want to think about what is the homogeneous solution, since we may run into some resonance. So here, to find the homogeneous solutions, the characteristic equation is r squared minus 5r minus 6 is equal to 0. And so this has solutions. R is equal to 6 and r is equal to minus 1. Since when we factor that, it factors into r minus 6 times r plus 1. So therefore, our homogeneous solution would be C1e to the 6t plus C2e to the minus t. And this is exactly why I wanted to find the homogeneous solution first, because notice this term over here has resonance with the 6t over here. So we do have resonance. So if I were coming up with my guess for this, initially I might guess y of p is equal to some general quadratic equation. So a t squared plus bt plus c times e to the 6t. But because we have resonance, we need to multiply this, where in this situation over here, we need to multiply by another power of t. So in fact, my particular solution should be y of p is equal to t times a t squared plus b t plus c all times e to the 6t. So because of the resonance, we would need to include that extra term there. And similarly, if we multiply a power function times forcing functions that have exponential times cosine or exponential times sine, then our guess, which was before exponential times cosine plus exponential times sine, rather than have constants in front of the cosine and sine parts, we're going to adjust this to put a polynomial, a general polynomial of degree n in front of the cosine piece, and then a different polynomial of degree n. So I've got different coefficients in this one in front of the sine piece. And again, we might have some resonance. So if when I solve the homogeneous part, I get a complex solution of alpha plus or minus I beta, then we would have some resonance with this situation, and we would need to multiply it just by one factor of t. So taking a look at question 6, we have the same homogeneous solution. So our homogeneous solution is going to be C1e to the 6t plus C2e to the minus t. And our forcing function is a product of a quadratic, exponential, and sine. So we actually don't have any resonance here, because the only way we would have resonance is if we had roots that looked like alpha, which is 6, plus or minus I times beta, which is 1. So since our roots are not this, we don't have any resonance. So we don't have to worry about any sort of correction when we come up with our guess. Okay, so we've got degree 2 times exponential times sine. So my guess, first of all, I better make sure I have a cosine and a sine in it, so don't forget that. My initial guess is therefore going to be some arbitrary quadratic equation. So I'll say a t squared plus bt plus c times the exponential with 6t in it times the sine of 1 times t plus, and now I need to add the same for the cosine. So I'll come down here since I'm running out of room, but in front of the cosine I would have possibly a different quadratic. So I'm going to say d t squared plus et plus f times e to the 6t cosine of t. And again, we don't need to multiply by another power of t because my homogeneous solution had real solutions and my forcing function would only have resonance if I had a complex solution that looked like 6 plus I. So that would be our guess. That would be a really hard problem to solve, so don't worry, I wouldn't ask you to actually find those coefficients, but what you should practice is thinking about what would be the correct guess. And so that's what the last problem in this set is going to make sure we hone in on those skills.